Okay, question 4 is about group 2. And remember, for group 2, for group 7, and to some extent for the acids and bases, there's a certain amount of factual stuff that you need to know. So if you find you're struggling, for example, with this first question about what's calcium hydroxide useful for, the important message is you need to go through your notes and actually learn the facts on these bits of the course. So, what's calcium hydroxide useful for in agriculture? The answer is to neutralise acidic soils, because plants don't grow very well in excessively acidic soils. So the use is to neutralise those. And why do you have to be careful? Well, it's an alkali, that's how it neutralises the acid, and so if you add too much of it, it will make the soils too alkaline for the plants to grow properly, so you need to make sure you only just neutralise it. Right, now the calculation. It revolves around this reaction, which here they were kind enough to give you, but remember they may not do that. That's one of the reactions that you need to know what happens when a group 2 metal is added to water. First thing it asks you to calculate is the mass of calcium, and you know immediately it says mass. The relationship is mass equals moles times, well, it's usually Mr, but in this case, because calcium's a metallic element, it's just moles times Ar, which is 0.00131 times 40.1 is the Ar of calcium, which is 0.0525 grams. And that's the answer for B, part 1. Now that answer then turns out to be useless. Usually in these questions, once you've calculated one thing, there's a reasonable bet that you'll go on and use that answer in the next part, but it doesn't always follow, and that's not the case here, so don't be thrown by that. Part 2, in fact, goes back to the moles again, and what it's asking us this time is to say, well, if we've got these 0.00131 moles of calcium, how much hydrogen will be produced? And the point about the equation is it tells you however many moles of calcium react, you get the same number of moles of hydrogen, because one calcium goes to one hydrogen. So we'll get 0.00131 moles of hydrogen. And for gases like hydrogen, the volume is equal to the moles times 24.0 dm cubed. In your data sheet, remember, it gives you that number. It tells you each mole of a gas occupies 24.0 dm cubed, and so you don't have to actually memorise that number, but obviously you need to know it's there. And so you can calculate that, 0.00131 times 24.0, which is 0.0314 dm cubed, because the volume is in dm cubed. And always be careful, here it does actually ask for it in dm cubed, so that's the answer, but be careful, sometimes it might ask for it in cm cubed, in which case you'd have to multiply by 1,000, but not here. Okay, now the third part you've got to be very careful with. As soon as you see something highlighted in bold, where it says hydroxide ions in bold, that kind of means be careful, you know, that they've put a little trick in here that you've got to make sure you don't miss. So what it's saying is that we've generated this calcium hydroxide in the reaction, and you can see, again from the equation, that the number of moles of calcium hydroxide is the same as the number of moles of calcium that went in. So you'll have 0.00131 moles of that as well. But it's actually asking us not about the number of moles of that compound, but about the individual hydroxide ions. So where you've got to be careful is that although you've got 0.00131 moles of that compound as a whole, each mole contains 2 moles of hydroxide ions. That's what that 2 there means. Okay, so for each lot of that compound is made up of 1 lot of calcium ions and 2 lots of hydroxide ions. So that implies that you've got 0.00262 moles of OH minus ions. Once you've got to that bit, the rest is easy, because it's saying that it's dissolved in 250 cm cubed, so the concentration of OH minus ions is the moles divided by the volume in dm cubed, which is 0.00262 divided by not 250 but 0.250. Remember, you've got to divide that 250 by 1,000 to get that volume in dm cubed, and that comes to 0.0105 moles per dm cubed. is the answer. Okay, next part says, okay, we did exactly the same thing, but now instead of calcium, we used barium. And the point is, barium is another group 2 metal. So the reaction is going to be the same, except that now we've got Ba instead of Ca. But although we've used the same mass, the important thing is that we haven't got the same number of moles, because the Mr is bigger for barium, and remember, moles equals mass over Mr, or Ar rather, for barium. Because that's a bigger number for barium, the number of moles is smaller. In other words, because it's, if you like, a heavier metal, the number of moles in that same mass is smaller, and therefore you'll get fewer moles of hydrogen produced, and thus the smaller volume. So remember, it's the number of moles that would have to be the same in order to get the same number of moles of hydrogen, and they're not. You've got fewer moles because the Ar is bigger. And finally, we've got to suggest one other difference that the student would observe between the reactions of water with calcium and of water with barium. And this is the trend down the group that you need to memorise. That as you go down the group, the metals become more reactive. And that's all you need to say, that the reaction becomes more vigorous or becomes faster because the metals become more reactive. In another paper they might ask you to explain why that was, and you need to relate that to the fact that the outer electrons become less strongly attracted to the nucleus as you go down the group. In other words, the ionization energies become lower, and therefore reactions in which those electrons are lost, such as the reaction with water, or the reaction with oxygen, or the reaction with acid, all of those are oxidation reactions of the group 2 metal, and they all become more vigorous as you go down the group because the outer electrons are easier to remove. Okay, but all you have to say in this case is just the reaction gets more vigorous, and that's it for question 4.